Diodes are called rectifiers. Capacitors are called filters. Transistors are called amplifiers. What does amplifier mean? In fact, I explained to you when we are studying chapter 5 section 3, I think. Yeah, at the end of the section when we are talking about the loudspeaker. So when we were talking a microphone, we said microphone produces an alternating electric current. This alternating electric current first amplified, then sent to the loudspeaker. Yani amplified means increasing the amplitude of the wave, increasing the amplitude of the electric signal, making it more powerful. So transistors are the devices which increases the power of an electric signal, yani amplified. In transistors, we are going to use a semiconductor, a type of semiconductor sandwiched between two other semiconductors. A piece of semiconductor of one type is sandwiched between the two pieces of the semiconductor of the other type. In here, N-type is sandwiched between two P-types. This semiconductor is called PnP transistors. In here, P-type is sandwiched between two N-type semiconductors. This one is called NPN transistors. Yeah, the one in the middle is sandwiched one. NPN. PnP. In your book, PnP type is explained. It will explain PnP type, but on basics, they have no big difference in their operations. Both can be used in electronic devices. But when you check their size, you are going to see that P-type is larger in size than N-type, because you sandwich it. Yeah? Sandwich has a smaller size. Huh? N-type is smaller in size. We know that in P-type semiconductors, positive charge, and holes are mobile charge carriers. Here are mobile charge carriers are holes. Here are mobile charge carriers are holes. But in here, in N-type, mobile charge carriers are negative, yani electrons are mobile in here. And also, in here, there are two, in fact, diodes combined. One PN junction is in here, between the P-type on the left and N-type in the middle. One more PN on the right as well. P-type on the right, N-type on the left. And there are two, in fact, you can put that a transistor is a composition of two diodes. One diode in here, second diode is in that. Okay, combine the two diodes, you form a transistor. PnP transistor. And because size of the P-type is larger, of course, P-type must contain greater number of mobile charge carriers, yani greater number of mobile holes. N-type is very narrow in size. That's why N-type must contain smaller number of mobile electrons. Okay? Let's continue studying the structure of a transistor. There are three semiconductors in here. One of them is, as you see, put on the left. The piece of the semiconductor on the left, on one end, is named as emitter. Yani this P-type is called emitter. The thin piece in the middle, which is N-type, is called the base. This is the base. Thin piece is base. And the piece on the other end, and on the right, which is P-type again, is called collector. This is a transistor, emitter, base, collector. There are two pieces, and each piece is an entry, a terminal. This is the terminal for emitter. This is terminal for collector. This is terminal for base. Transistor is the only device which has 3 terminals, 3 legs. If you check an electronic device, you can easily understand which one is a transistor because it has only device which has 3 ends. Resistor has 2 ends. Capacitor 2. Diode 2. Transistor 3 legs. It stays just like this on the surface of the electronic device. And as I said, by the time this is the symbol of the transistor in electronic circuit. There's a circle. Emitter is on the left side. Collector is on the right side. Base in the middle. This is the symbol of a transistor, and this is the ministry exam question. When you check ministry exam, you will see that. And this emitter, base, collector, between emitter and base, you see there's a junction. Between collector, base, there's one more junction. How many junctions are there? 2. In diodes, normally we have 1 junction, but in transistors, we have 2 junctions. One junction is emitter base junction. The other one is collector base junction. There are 2 junctions in this transistor. For that, as in this transistor, sometimes called as junction transistor. Junction transistor. But each junction some junctions are forward bias, some are reverse bias. In here, emitter base junction is forward biased. What does it mean? It lets electric current in this direction. But collector base junction is reverse bias. What does it mean? It does not allow electric current in this direction. It must be, electric current of this one must be in the opposite direction. So, forward biased, reverse biased. Which one is forward biased? Emitter base junction is the forward biased, but collector base junction is reverse biased. And as I said, emitter, the semiconductor, the P-type semiconductor on the left is wider in size. Wider in size means there are greater number of mobile charge carriers holes. But base, very thin. Thin means smaller number of mobile charge carriers electrons in the base. That's why more charge carriers in the emitter than in the base. More charge carriers in the emitter than the base. Reason is what? This is very wide in size, but that is very thin in size. We did the equal, but normal not. To show them we make them. Very great in size compared to the base. Base is so thin. That's why base has smaller number of mobile charge carriers. That's why we explain emitter is more heavily doped than the base. Emitter is more heavily doped than the base, which means emitter has a greater number of charge carriers than the base. Emitter has a greater number of holes than the number of electrons in the base. And on that, this is the key. When we are explaining how it works. Okay? Until here, any questions? This is how we define the transistor. These are the definitions. Now, we said that transistor acts as amplifier. How could it amplify an electric signal? Now we are going to talk about this. 2 batteries are necessary to properly bias a transistor. Bias means connect. We use a special word bias for electronic devices, for semiconductors, but it means in fact connect. 2 batteries are necessary to properly bias a transistor. One battery will have a potential difference delta VEB. EB. E emitter. B. This battery will be connected between emitter and base. delta EVB, a battery feeding the input source. Input source is what? I'm talking what? Microphone. Input source is microphone. Microphone produces a weak signal. So a battery feeding the input source, a microphone. So this input source is connected between emitter and base. And there's a potential difference for the battery, of course. Delta EB, delta VEB. Where is the second battery? Delta VEC, EC, between emitter and collector. A battery feeding output source. Of course, what is output source? For the microphone is the input source. Output is loudspeaker. Loudspeaker. It must be connected between emitter and collector. Here's your question. Input source is connected between where and where? Between emitter and base. Output source is connected between where and where? Emitter and collector. Yeah, loudspeaker will be connected between emitter and collector, but microphone will be connected to between emitter and base. Of course, each of them needs a battery to provide electrical energy. But only difference is microphone has a small battery, but loudspeaker is connected to 220 volts. Yani battery of the output source is more powerful than battery of the input source. Now let's go and understand how it works on this diagram. I said that because emitter is greater in size, it contains more free charge carrier, more mobile holes than the base. Base has smaller number of electrons, mobile charge carriers, but emitter has greater number of charge carriers holes. And because emitter base junction is forward biased, this junction lets holes to go from p-type to n-type to join with the electrons. They join, remember, their tendency is to meet. But emitter has 1,000 holes. Base has only 10 electrons. How can they join them all? They cannot. So 10 electrons in the base can only join with 10 holes from the emitter. And these 10 holes from the emitter joins with 10 electrons in the base with electrons and produces a current which is IP, base current. But what about the rest of the holes? 990 holes are staying in here to combine with electrons. But base has no more electrons. What's going to happen? Look at now here. This is negative, huh? This is a very huge, powerful battery, 220 volts. And negative terminal of the battery is connected to where? Collector. Here are holes. These holes are still looks for negative. But here is we have greater number of negatives. They says, okay, this negative tells you, come. Let's join. Yes. Electrons from this negative terminal of the battery is joining with the holes which are left in here. So then these 990 holes starting to pass through the base and combining with the electrons from the collector and leading a very big current, collector current. That's why collector current is much greater than the base current. Only 10 holes produces this IE, but 990 holes produces this IC. IC, collector current, is always greater than base current.
The negative part of the battery joins with the...
Yes, of course, because negative is attached in here. So this negative terminal provides electrons for those holes, which are looking for negative in the base. And then they start combining. So shortly, let's explain. Because emitter is heavily doped relative to the base, a few electrons and holes combine in the emitter base junction and forms a small base current. But most of the holes from the emitter do not recombine with the electrons in the base because there are no more mobile electrons. Because the base is very narrow, less number of electrons exist there. Then, once these holes are in the base, which are 990 of them, they enter the strong influence of delta VEC, and this negative strong influence pulls them. And these holes start to combine with electrons from the negative terminal of the output source and lead a large current IC. IC is much larger than IB. When we divide IC by IB, we calculate a constant for that transistor. That constant is represented by beta and called current gain. Current gain. Every transistor has a current gain. But because IC is greater than IB, what do you expect beta to be? IC over IB? Greater than 1? Equal to 1? Or less than 1? Greater than 1. Let's check some question. Current gain of transistor A equal to 1. Less than 1 or greater than 1? Because IC is much greater than IB, IC over IB must be greater than 1. This current gain of a transistor is greater than 1. And this is the question. Okay, so now let's continue and see that how we are going to convert weak signal from a microphone to a very powerful signal in a loudspeaker. This is the diagram how we are going to connect a loudspeaker and a microphone to a transistor. We said that input device must be connected between base and emitter, correct? This alternating current, alternating generator symbol is representing the microphone. Because when you are talking to the microphone, you are producing an alternating current. This is representing microphone. And microphone, which is the input device, must be connected between the base and emitter. Of course, the input device will have its own potential, a battery, which is a low potential battery, but it must be. Because we need a signal. This signal will be produced by a battery, of course. And second device is a loudspeaker. This is representing loudspeaker, this resistor. It is connected between where and where? Between the collector and emitter. Yani output source is connected between emitter and collector. Of course, it needs a very powerful battery, right? 220, because you plug loudspeaker to 220. It must be so high battery. Then what's happening? A small variation in the base current, IB, produces a very quiet change, very light change in IC. Because IB and IC are directly proportional, we know that. We know that. Say that IB changes from 0.1 ampere to 0.2 ampere, correct? How many times IB changed? How many times? How many times? 2 times, twice. It changes twice. IC also changes twice. But IC is great in number. It changes, and a random number I am giving. It's changing from 2 ampere to 4 ampere. It's also twice. But this changes how much? 0.1. Because 0.2 minus 0.1, very small is the change. But 2 minus 4 minus 2, 2. This is how we are making the amplitude of the output signal greater. Yeah, yes, there's a proportional change. However, current of IC is much greater than IB. When IB doubles, IC also doubles. However, IB doubles from 0.1 to 0.2, but IC doubles from 2 to 4, or 20 to 40. That increase is so huge. That's why we are making the amplitude of the output signal much greater, higher than amplitude of the input signal. As amplitude is smaller, power is smaller. As amplitude gets bigger, power gets bigger. Then we are sending this IC to where? To the loudspeaker, and we get a very intense, powerful sound. In here, what is happening is this. IB and IC changing directly proportional. Only IB is a very small current, which is the microsurge current. It's when this current doubles, that current also doubles. The only difference is that current is provided by a very strong battery. So it's also doubles, but doubles from 2 to 4 or 3 to 6 or 5 to 10. The change is so huge. This change makes the amplitude. Amplitude becomes so large. That's why power becomes so large. This is what we have to know. How we amplify an electric signal by this way. So a small variation in the base current IB, which is input signal, this one, leads to a quite large change in the current of IC, which is output signal, and the transistor acts as a current amplifier. Current amplifier. The collector output current is directly proportional to base current. I said this before. Yani IC and IB are directly proportional. Yani I beta, which is current gain, is equal to IC divided by. If I cross product it, I will get this equation. IC is equal to I beta times IB. This is a ministry exam question. And they ask, what is the equation for current gain of a transistor? They write this equation. But if which I will take a question. And this beta is called current gain. As I said, this current gain always greater than 1 for a transistor. Never less than 1 or never equal to 1. This is also an exam question. And it has no dimension because you divide ampere by ampere. So it's just a number, pure number. 10, 20, 30, and so on. And every transistor will have a 10 current gain. From 10 to 1,000, say 100. Yeah, a transistor can have 10 current gain, 20 current gain, 30, 40, 50, depending on the purpose of use for that. Okay, this is how transistor acts as a current amplifier. How transistor acts as a current amplifier. And one more short title in here we have, which is called integrated circuit. Integrated circuit. What is integrated circuit? Chip. Maybe you heard chip. Every electronic device is chip. Every electronic computers have chips. Those things are chip. Integrated circuit. Integration means collecting the things. Integrated circuit is a collection of interconnection of transistors are connected to each other, diodes, resistors, capacitors, all are fabricated and located on the surface of a piece of silicon. This is a piece of silicon on which you are inserting those components. And these lines are connecting them one another. This is called the integrated circuit. Other name, chip. A chip contains several hundred thousands of components in a very small area. In here, how many these are all resistors. There are most probably 3 lakhs transistors, 2 lakhs capacitors on the other side. It's the back of this one, you see how they are connected. Because you make them very close to each other, electric signal can go in a shorter time from one component to the next one, which makes the chip faster communication. Integrated circuits have an advantage of miniaturization, yani smaller in size. When they are smaller in size, of course, they communicate much faster. Fast response, which is very important for high-speed operations. And response time is defined as the time it takes for electrical signal to travel from one component to another. If response time is small, it's a fast device. But if response time is long, it's a slow device. Response time is the time it takes for electrical signal traveling from one component to another. This time is reduced by closer packing of the component, and you are making a faster computer or faster device, whatever it is. Okay? And first type of integrated circuit is it's a calculator, which is called operational amplifier. Operational amplifier means calculator. First type of integrated circuit is an operational amplifier, yani a calculator. A calculator is used for making addition, subtraction, division, and so on. Right? So they are the basic element used to perform mathematical operations, additions, multiplications, divisions, and subtraction, and so on. This is the schematic diagram of a calculator. How additions, subtractions, or divisions are done by a calculator is about, in fact, potential difference provided to the transistors. The numbers involved in the operation are the values of input and output potential difference. Remember, every transistor has an input potential, input current, which is base current, and output current, which is collector current. And collector current is always greater than input current. Yani when you give 5 volt potential difference, 10 to 5 volt potential difference, to a transistor whose current gain is 5, output becomes 25. So numbers are involved with the potential difference. Number 5, say that corresponds to 5 volts. Number 10 corresponds to 10 volts. For example, 5 times 5, 25, right? So when you press the 5, you are sending 5 volt to the transistor, multiply, so you are connecting the transistor in series and parallel, and then when you put equals is another number, result is 25. So output potential difference becomes 25. Yani measure of the numbers, those calculated are in fact measure of potential difference of the inputs and outputs. Addition, subtraction, division. You are connecting these transistors in series, in parallel, and you are making the change in the current gain of this combination. Basic operation of the calculators are this. No? Only these are the things you have to know, and no other explanations given in your book. Even I explain in more detail than this one. Okay? One question we will solve, which is one of the section question. After that, we will finish this section. It is this question. General students ask this one to me. That's why I will solve this. The rest of our section questions are very easy. You are going to do on your own. If a transistor circuit is used to amplify 2.5 microampere, this in your malzeme I know that it's milliampere, but it must be micro, okay? Change this to the micro. We want to amplify 2.5 microampere electric current to 0.1 ampere. So you can predict which one is the base current, which one is the collector current. Base current always small. Collector current is always big. So microampere is smaller. It must be base current. But 0.1 ampere must be collector current. So we are amplifying 2.5 microampere to 0.1 ampere, but how? By using transistors, of course. What must be the minimum gain of the transistor circuit? In this circuit there are maybe more than one transistor circuits. How can we calculate the current gain beta? IC divided by IB. IC is 0.1. IC 0.1. IB is 2.5 microfarad. We know 2.5 microampere, sorry. 2.5 microampere is converted to ampere by multiplying 10 to the power negative 6. 2.5 times 10 to the power negative 6. Divide them. Result will give us the current gain of this circuit, which is almost 40,000. 40,000 is the current gain of that transistor circuit. B part is asking you, assume the amplifier consists of a number of transistors in series. This time in this circuit, they are connected in series. Each with a gain of 10. And each transistor has a current gain of 10. How many transistors are needed in this circuit? Hint. 2 such transistors in series would provide a total current gain of 10 times 10. Yeah, if you connect transistors in series, you are going to multiply their current gains. One transistor, single transistor, has just a current gain of 10, so result is 10. But if you connect 2 transistors in series according to this given hint, if 2 transistors are connected in series, you should multiply the current gain of each. 10 for the first transistor, 10 for the second transistor, multiply them, result is 100. Still, we didn't catch this number. We should catch 40,000. Then we should add one more transistor in series. For 3 transistors, first one is 10, second one is 10, third one is 10, multiply them all, result is 1,000. Still, less than 40,000. Continue, add one more transistor in series. Let's do 4, first, second, third, fourth, multiply them all, it is 10,000. Still less than 40,000. We should add one more. When we add 5th transistor, 1, 2, 3, 4, 5, multiply them all, it becomes 100,000. 100,000 is greater than 40,000? Yes. 40,000 less than 100,000? Yes. So, minimum we need 5 transistors to get this current gain in that transistor circuit.